In this session, we take a deeper look at RAM, which leads us to define the terms bit and byte. Then we look at how data is stored and located on disk, finishing up with a brief survey of common I/O devices. Let's explore RAM a little more. Although the acronym stands for Random Access Memory, it does not mean that things are stored randomly. Random in the computer world is a synonym of direct, meaning to find instructions or data in memory, you go directly to the location where they're stored, as opposed to having to begin at the beginning and search until you find what you are looking for. There are two classic ways of visualizing RAM. The first is a very long string of bytes. A byte is enough room to hold one character, so you might see something like this. The second way of visualizing RAM is a great sheet of paper divided into blocks of 1 byte each, maybe something like this. And both of these representations are helpful. RAM is volatile. That is, when you turn off or restart your computer, all the data currently in memory is gone. When you turn on or boot your computer, the hardware and software work together to load the operating system programs into RAM, then paint your screen with the chosen background and display the icons for your apps. Computers are binary things. They work with tiny electronic switches that can only have two states, off or on, like a light. To help us grasp what's going on, we often represent these states as the number 0 if the switch is off, or 1 if the switch is on. This is called a bit from the phrase binary digit, a number that can have only one of two values, 0 or 1. Each byte is composed of 8 bits. So each byte of memory can be thought of as a string of ones and zeros. All data and instructions are bits, ones and zeros, organized in groups of 8 bits called bytes. It's the patterns of ones and zeros that are interpreted as instructions or characters and so on. And this is as deep as we're going to go on that front in this series. When the system loads a program or data into memory, it has to know where in memory which bytes should get the data. What memory locations will be used? Fortunately, memory management is one of the tasks that Windows takes care of, so we don't need to worry about it. Now let's turn our attention to data on disk. A disk is actually composed of one or more platters, where data is recorded along tracks, concentric circles. Tracks are further divided into sectors of equal capacity. To locate a program or data on a disk, you need to specify which sector or sectors they're stored in. Fortunately, that's part of the responsibility of Windows, so you don't need to worry about that. Now the platters are stacked on a spindle, and each platter is accessed by a read-write head that can locate the correct track and sector on the platter to read data from or write data to. The details, again fortunately, are handled by Windows. And we end this session with a quick survey of some of the I/O devices you might have on your system. Your screen is, of course, an output device. Windows is inherently a visual operating system, and it is constantly painting the screen. The screen is actually composed of tiny dots, each of which can have a color and brightness assigned to it. These dots are called pixels, short for picture elements. The number of dots you can squeeze into your screen, called the resolution, determines how smooth images may look to you and how many images will fit in the screen area. Many computers these days come with screens that are touch sensitive, in which case the screen can be an input device as well as an output device. The keyboard is obviously an input device. Each keystroke sends a character into RAM, and Windows displays the character on the screen using the current font. Well, as you know, some keys have functions rather than characters assigned to them. For example, the Shift key and the Control key, the Alt key, that is the alternate key, Tab keys, the function keys, and so on. The mouse is an input device. Computer mice have a left button and a right button, and in some cases a middle button and/or a mouse wheel. Windows shows a cursor on the screen, and moving the mouse moves the cursor, shifting attention to different parts of the screen. If you click on the left button, that sets the focus to the object where the cursor is found. If you press and hold the left key, you can then drag the object where the cursor is. Lifting your finger off the key drops the object to where the cursor has been moved. If the cursor is positioned on text, dragging the mouse highlights the text. Then a right click will pop up a menu of choices. If you double-click the left button while the cursor is over an icon, that will launch the program that the icon represents. A double click is 2 successive clicks done quickly. If you click the right button, you will usually bring up a dialog box where you can examine and sometimes change the properties related to where the cursor is located, or issue a command like copy, cut, delete, rename, and more. Much of the above is discussed further in later sessions. Many systems these days come without a mouse, but instead have a trackpad or touchpad built in on the keyboard. Moving your finger over the trackpad moves the cursor on the screen, and you can left-click, double-click, and even right-click. Different kinds of trackpads have different ways to do this. Personally, I don't have the fine motor skills to use a trackpad effectively, so I purchased a mouse to use with my system. Printers are, of course, output devices. External disks includes classic disk drives, thumb drives, also called flash drives and USB drives, and CD, DVD readers and players. Microphones are input devices. You can get them built in or separately purchased and installed. Speakers are the same way. They're output devices that you can get built in or separately purchased and installed. And network adapters. Input-output supports Ethernet, Wi-Fi, Bluetooth, and so on. Windows is actually designed to support a wide variety of devices, even more than the list above. But it all comes down to bits and bytes flowing into and out of RAM and the processor. In the next session, we discuss how to organize your Windows desktop in order to minimize distractions and maximize effectiveness. See you there.